Right, this example is a two-step metric conversion problem, which means we will need to do two conversions in order to get to the unit that we are looking for. The question asks for centimeters. You are given kilometers. Notice that the base unit here is meters. Both centimeters and kilometers both have a prefix. So centi means 100. You can think about it like there's 100 years in 1 century. Okay, so 100 centimeters equals 1 meter. And we know that 1,000 meters equals 1 kilometer. I did not give you the conversion factor between centimeters and kilometers, so we will do two conversions to get the answer. Okay, just like before, start by writing the given information. That is 3 kilometers. We're going to multiply that by the conversion factor, which we write as a fraction. So the first conversion factor we're going to use is 1,000 meters equals 1 kilometer. So if kilometers is on the top, we know that kilometers goes on the bottom of the next step. The number that goes next to kilometers is 1. Notice in each conversion factor, the 1 always goes next to the larger unit. Kilometers are larger than meters. 1,000 meters goes on the top. Okay, so 3 times 1,000 divided by 1, kilometers canceled out, and you will get 3,000 meters. So whichever unit you're left with on the top, that is the unit that you currently have. Next, we're going to convert meters to centimeters. We know that there are 100 centimeters in 1 meter. Okay, so we're going to move the decimal place 2 places to the right. Since we're multiplying, we know the number gets larger. You will get 3,000, 2 more zeros. Okay, so your answer is 300,000 centimeters. Okay, and typically we would write a number this large in scientific notation. So the decimal place if there's no decimal place in the problem, we can assume that it goes at the end. Okay, so it's 300,000. For scientific notation, we need the decimal place to be after the first non-zero digit. That would be right here. So that the distance between where the decimal place is and where we want it to be is 1, 2, 3, 4, 5. So 3.0 times 10 to the 5. Okay, and we know that it's positive 5 because the original number was greater than 1. If the number is less than 1, then our exponent will be negative. And you can always check your work. So if you have 3.0 times 10 to the 5th, we know if we move it 5 places, 1, 2, 3, 4, 5. Okay. We have correctly expressed our original number in scientific notation.